All right, you have put in the hard labor. You have worked so hard for so long. Let's end with something that puts together the whole unit in a pretty bow. Well, with a pretty bow. Let's take a look at one of Euler's most famous equations, certainly the one that every student comes out of Calc 2 knowing and appreciating. So you and I both know that e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on, right? Leonhard Euler, some 300 some odd years ago, said, you know what? Let's do this. Let's take a look at what e to the I theta is. Now, that's a little odd for a couple of reasons. One, we don't study the imaginary units in our course. This is a real valued function course. We don't deal with I at all. So if you don't understand a word that happens after this moment, you're still okay for our Calc 2. But you might remember something about I from Algebra 2, and I'd like to talk a little bit about that. Here's what Euler does. He said, let's figure out what e to the I theta is. Now, theta is an angle, like you're familiar with from school, and I is the imaginary unit, like you're familiar with from school. And what we do with it is exactly what we have been doing with it. We replace all the x's with I thetas. I theta squared plus, and so on. Okay? So then you get thinking about, well, what about the powers of I? And we remember, because we went to school once, so we remember that I squared is -1, and I cubed is I squared times I, and I to the fourth is I squared squared. And those have an effect on what happens here. And so Euler figured out that all the even terms, all the even powers end up with regular numbers, and all of the odd terms end up with i's or negative i's. So let's break them apart. All of the even terms, well, that's, let's see, how does that work out? That's a 1. I squared is -1. I to the fourth will be +1, and so on. And then here's an I theta, and this is going to be a -I theta cubed. And then there's going to be an I theta to the fifth, and so on. And Euler said, well, like, I love this idea, but we could probably pull an I out of each of those. Under no other circumstances do I recommend you pull an I out of anything. Let's just be clear about that. So if we factor out an I from this series, what's left? Now, what he noticed is powerful. So take a moment and think about, what's the red series? What's the blue series? Boy, I hope you remembered that the red series is cosine. And I hope you remembered that the blue series is the series for sine. And so Euler has this relationship that connects exponential functions with trig functions using imaginary numbers. And then if we consider what happens when theta is pi, then we see that e to the I pi is -1 plus 0. That's just bizarre. That's bizarre. You take our number 2.718281828459045. You raise it to an imaginary power, but not just an imaginary power, an irrationally imaginary power. You get -1. That is mind-blowingly ridiculous. And it helps us remember all the things we're supposed to remember about all these Taylor series we've been using in all these weird ways. So I hope this is a nice way for us to close out our study of infinite series, and I wish you well as you prepare for what is coming.